Okay, hello everybody. I just finished our Zoom class. 4 students came, but I decided I didn't actually decide. Kashama, one of the students in class, wanted to see how to do base 10 to base 2 and base 2 to base 10 conversions, just for our own benefit as a computer science major. It's a good idea, so I'm going to post a video on that. And to do that, I'm going to go to the whiteboard because it is kind of a math thing to do. So I'm going to bring up the whiteboard here on Zoom and then show you how to do it. Okay. So the first thing we're going to do is a base 10 to base 2 conversion. So I'm going to pick a random number like 26. 26 is a base 10 number. All the numbers we work with are base 10. And I'm going to show you how to convert that to binary, to base 2. Now, binary is made up of zeros and ones. And the key thing here is to know the place values of binary numbers. So whereas the place values of our number system, you may recall from like second grade, this is the ones place, and this is the tens place, right? So this is like the equivalent of 6 ones and 2 tens. But in binary, I'm going to use this 3 symbols here, meaning equivalent to. In binary, we have place values that are base 2. So if you think of our base 10 number system, the 6 is in the ones place because that's really 10 to the 0 power, right? Oh, actually, that's 10 to the 0 power, which is 1. 10 to the first power, which is the tens place. 10 to the second power is the hundreds place, and so on. So in binary, the place values are base 2. That means you have a binary value of the first place would be 2 to the 0 power, which is also a 1. The second place would be 2 to the first power, which is a 2. The next place, as we move to the left, is 2 to the second power, which is the 4's place. 2 to the third power is the 8's place. 2 to the fourth power is the 16's place, and so on. So you have place values of 1, 2, 4, 8, 16, 32, 64. It's just a doubling of each previous place value. So the number we're trying to do is 26. So the one algorithm says, let's go to the highest place value that fits inside the 26. So if you try going to like a 32, that's too big, right? Because 32 is too big. There are no 32s inside of 26, but there is a 16. So we're going to put a 1 in the 16 place, right? And if you subtract away that 16, 26 minus 16 leaves you with 10. So that means we have to account for 10 more in the representation of 26 into binary. So if we go to the next place over is an 8, which does fit into the 10. So we need 1 8 there. Subtract away 8, and that leaves us with a 2. If we keep going, a 4 does not fit into the 2. So there are no 4s, but there is a 2. It's exactly a 2. And when you subtract away that last 2, you're left with 0. So there is no more. So the representation for 26 in binary, read from left to right, would be 1, 1, 0, 1, 0. So that's how you do 26. So any number can be converted from base 10 into binary doing this sort of particular method. Now there is another method, and this other method is a little bit slower. I'll do a different number here. Let's take the number 19. And the way it works is you just keep dividing by 2 and keep track of the remainders. So we're going to represent 19 in binary. So how are we going to do that? We're going to take we're going to divide 2 into 19, which goes 9 times, but the remainder is 1. We're going to keep dividing. 2 into 9 goes 4 times, and the remainder is 1. 2 into 4 goes 2 times, the remainder is 0. 2 into 2 goes 1 time, the remainder is 0. And 2 into 1 finally goes 0 times with a remainder of 1. So 19 is equivalent to, in binary, read from left to right, from bottom to top. In other words, we would write 19 is equivalent to, from the bottom, 1, 0, 0, 1, 1. So that would be in 19. And we know that to check that, or to go from binary to base 10 or decimal, we look at all the place values. So remember, the place values are 1, 2, 4, 8, and 16. So if you look at the numbers where there's a 1, well, there's a 1 in the 1's place. There's a 1 in the 2's place. No 4s, no 8s, but you do have a 16. So if you add those numbers together, 1 plus 2 plus 16 is 19. So that's basically going from binary, base 2, into base 10 by remembering or writing down the place values and looking at where the 1s are. And that's how you convert from base 10 to algorithms to base 2, and also from base 2 to base 10.